going to use the process of completing the square in order to write this expanded circle equation as in standard form, which is x minus h squared plus y minus k squared equals r squared. So what I need to do is complete the square with my x terms and with my y terms in order to move toward having these perfect squares in my equation. Let's start with the x minus 2x terms. I'm going to rewrite these as x squared minus half of negative 2x twice. So half of negative 2x is minus x. I'm going to write minus 1x for now, just it's easier to keep track of. And I'm bringing down everything else. Plus y squared plus 10y plus 22 equals 0. All right. Considering only these terms, I'm going to rewrite my, x terms here as a perfect square. It'll be x minus 1 squared. All right. The minus 1 comes from the coefficient after I split my regular x term. So this minus 1 is what becomes this minus 1, right? These are all the same. But x minus 1 squared has that extra plus negative 1 squared term in it, right? If I do off to the side, if I just do x minus 1 times x minus 1, I get, oopsie, x times x and x times negative 1. And then I get negative 1 times x and negative 1 times negative 1. So this plus 1 comes from the negative 1 times negative 1. So I didn't have that term of plus 1 in my original equation. So I'm both going to add it and subtract it. When I do that, this group becomes my perfect square, and I bring down my minus 1 plus y squared plus 10y plus 22 equals 0. I can combine that minus 1 in with my 22, and I will in just a minute. But before I do that, I want to complete the square with my y terms. I'm going to erase off this scratch work here because we're going to do it again. Considering only my two terms with y in them, I'm going to rewrite it with that 10y split in half twice. So plus 5y plus 5y. I'm going to copy everything down. Notice I left some space here because I know I'm going to be adding and subtracting the perfect square of 5. This is 5 squared. All right. The reason we do that is because I know that these terms, this part of the group, is going to equal a perfect square of y plus 5 squared. But if I multiply out y plus 5 times y plus 5, I am missing my plus 25 term. That comes from doing y times y and y times 5. And then 5 times y and 5 times 5. And so it's this plus 25 that's needed. And it's always going to be that square term that we're missing. So I'm going to both add it and subtract it so that I can regroup these. I get x minus 1 squared minus 1 plus y plus 5 squared minus 25 plus 22 equals 0. Now we can combine all of our constants, -1, -25, and positive 22. This gives us -1 and -25 is -26, with a positive 22 that leaves us with -4. So we have x minus 1 squared, like where my minus 1, plus y plus 5 squared minus 4 equals 0. I'm going to add 4 to both sides, and that will solve it. So my completed equation is x minus 1 squared plus y plus 5 squared equals 4. And notice in this problem, I need to find the center and the radius of this circle. So this is my equation. Remember that h comma k is my center. So what I have here is h is equal to 1. Notice the subtraction is in the equation. So x minus h, my h is -1. Y plus 5 is the same as y minus -5, which tells us that k equals -5. And r squared is equal to 4, which means that r is equal to the square root of 4, which is 2. So my radius is 2, and my center is 1 comma -5. And my radius is 2. All right, and that is how we complete the square to solve that problem.